channel. So today we just see about some interesting topic, that is what you call the thermodynamic systems. So we know that thermodynamics means there is some amount of heat transfer. Thermo means it is a heat and dynamics means it is a transfer or something, that is a movement. Okay, so we having the thermodynamic systems in three different forms. One is called isolated systems. Okay, so in this isolated system means it can neither transfer the energy or nor the matter, which will never be transferred, which means it will be there only, so it will not have any moment. That is what you call that isolated. Okay, so here you just take that there is a two different case studies. One is called a closed system and another one is called open system. Here closed system means the exchange of energy will takes place, but there is no symbolic representation of heat transfer. But in the case of open system, there is we having that both the matter and as well as matter represents it is a mass of the particles, and there is a energy and as well as the mass transfer will takes place. So that is the difference between the open system and the closed system. So generally we use the process for when the when there is a movement either by liquid or gas because of the heat, we we use it to study the process is called a quasi-static process. The meaning of quasi means there is some amount of equilibrium. Okay, it is an equilibrium state. Okay, so generally it can be classified into three different states. One is called initial and intermediate and as well as the final state. So it can be represented by P, V, T, which means P represents it is the pressure, V represents it is the volume, and T represents it is the temperature. Okay, so in this case the quasi-static process means here it is sufficiently slow process, and at any intermediate state can consider as a thermo-equilibrium, which means the thermal equilibrium means it makes sense to define the temperature. So there is a stable temperature which has been transferred. So we having 3 or 4 different laws. The first one is an isothermal. Here iso represents same or otherwise constant, and thermal represents it is the temperature. And second one, there is an isobaric, where iso represents same as like a constant, and baric is nothing but you just need to split the word into bar. Okay, so bar means it is the unit of pressure, therefore it represents pressure constant. Similarly, isochoric, choric represents there is a volume, that is a cubic. Okay, so that is what you call that volume constant and adiabatic. So when you take this case in the thermodynamics, there is two images what you have seen in the screen. The first one, there is a piston, motion of the piston in the right to left direction, which means the piston moves towards the molecule during collision, and the molecule gains the kinetic energy, thus negative work on the piston has been done. And the second case, because of the molecule collision, that the molecule delivers the kinetic energy or otherwise loses the kinetic energy, therefore the work of the piston has been reduced, hence it becomes a positive work on the piston. So that is what here in this both diagrams which has been explained clearly for the forward movement and the retract movement. Forward movement represents if there is an because of the collision of the molecules, if there is no work has done by the own piston, therefore here it is called positive work. In the second case, you just need to take if the piston has done the movement either in retract direction, it may be it doesn't happen because of that molecule collision, but we just need to give some amount of work to the piston. Okay, so both the cases were entirely different, so that is why we need to represent that positive work and as well as the negative work. Okay, so here in technical terms we use that the forward and retract movement. If you take a forward movement, it is called it as a compression. If you take a retract movement, it is called it as an expansion. So that is what you used to see in this slide. So work during the volume, it can be calculated with respect to that differentiation. dW is equal to F into dx, which means the work done because of the force. We know that the relation between the force and pressure and area, F is equal to P into A. So that is why this equation has been represented. Work done is equal to pressure into area. That dx represents, it is the distance traveled by the piston. We know that area into distance is what you call, it is the volume. Okay, so that is why we need to represent the work done is nothing but it is the integration of both the pressure and as well as that volume. So we just come across that so many pressure volume diagrams, and here the volume increases and pressure also increased. The volume decreases and pressure also decreased. So this is the basic difference which made us sense to compare about these three things. So anyway, thank you so much. We will see you in next class.